Welcome back to All This Math. This is Professor Parker, and today we're doing some work with addition of mixed numbers. The addition of mixed numbers. So take a moment, pause the video if you need to, and copy down this problem into your notebook. 31 and 8 ninths plus 6 and 5 ninths. Now, first off, why is this called a mixed number? It's called a mixed number because it's mixed up. It's made up of two different types of numbers. It's made up of a whole number and a fraction. 31 is the whole number, 8 ninths is a fraction. 6 is a whole number, 5 ninths is a fraction. Now, the way we add these is, we add them similar to the way that we would add fractions. We want to check to make sure that we have a common denominator, meaning that each mixed number has the same denominator. And of course, the denominator is the number at the bottom of the fraction, whereas the numerator is the number at the top of the fraction. So in our first mixed number, our fraction is 8 ninths. Numerator is 8, denominator is 9. Second mixed number, our fraction is 5 ninths. Numerator is 5, denominator is 9. Now, lucky for us, we don't have that much work to do. We don't have as much work to do as we could because our denominators are already common. We have the same denominators. So what that means is all we have to do is add the numerators. Because when you think about it, a denominator is a number, but it's not really treated like a number. A denominator is kind of like a unit. It's kind of like miles or years. Like if you describe somebody's age, you say they're 10 years old or 13 years old, right? Or if you say, well, how far is this city from that city? You say 300 miles or 200 miles. In a fraction, what we're doing is we're saying, okay, this is how many, this number right here, the numerator, is telling us how many ninths we have, right? So let's say we took a circle, right? Broke it down into 9 equal parts, cut it up into 9 equal parts, and then we took 8 of them. That would mean we took 8 ninths because each part is equal to 1 ninth. That's called our unit fraction, right? So each part is a ninth. And if our numerator is 8, that means we got 8 of them. We got 8 ninths. Then in this mixed number, we got 5 ninths. So we took another circle, broke it up into 9 equal parts again. Each part is worth 1 ninth, right? Because it's 9 equal parts. So we got a ninth, another knife, another knife, another knife, another knife. We got 9 of them all together in the whole thing. But if we take out 5 of them, that's 5 ninths. So the question is always how many ninths or how many of the denominator did we have or did we take or did we use, etc. And that question is answered by looking at the numerator. All right. Now, in terms of how we're going to add these mixed numbers, you first add the whole numbers, right? So the whole numbers are 31 and 6. So we want to add them up real quick. We want to do 31 plus 6. 31 plus 6 is going to give us 37. So I'll write my 37. Boom. So that part is done. You add the whole numbers first. That gives me 37. Then you go and you add the fractions. So how many ninths do I have right here? I got 8 of them. How many ninths do I have over here? I got 5 of them. So if I got 8 ninths plus 5 ninths, that's like saying it's 8 people and 5 people. So altogether, how many people is it? 8 plus 5 is 13. So I got 13 ninths. Now, I look at that and I read it, and it says 37 and 13 ninths. That sounds weird. And if it sounds weird to you, good, because it should sound weird because this fraction that we had, that we just created, doing the correct work, right? Because that can happen sometimes. We did the right thing and got something that sounds weird, right? But we could fix that. Don't worry about it. We could fix that. The numerator should never be bigger than the denominator. When that happens, there's a term for that. That's called an improper fraction. It's called an improper fraction. At the end of the day, we only want to deal with proper fractions. We always want our numerator to be less than our denominator. All right? So what we're going to do is we're going to take this fraction and convert it to a mixed number. And then we're going to add it to 37. Because the way I would read this is 37 and 13 ninths. The word and in mathematical language means addition. So I would take 37 whole pieces and add it to the 13 ninths. Now, how do I change 13 ninths into a mixed number? That's the question. All right. Basically, I'm just doing division. I'm really doing 13 divided by 9. But the way I like to describe it is I like to use a method I call musical chairs. Because I think about it like this. The denominator, imagine this scenario. You got groups of people that are going into a restaurant or auditorium. It could be an auditorium at school. It could be a restaurant, it could be a cafeteria, whatever. But it's only a certain amount of chairs in that space. There's only a certain amount of chairs in that space, right? So the denominator tells us how many people are in one group. That's what the denominator tells us. The denominator tells us how many people are in one group. So in this particular situation, it's 9 people in a group, right? 9 people in a group, all right? Now, what does the numerator tell us? The numerator tells us how many empty chairs there are at first, before anybody comes in and sits down. So the question we got to ask is, how many groups of 9 can fit into 13 chairs? How many groups of 9 people can fit into 13 chairs, right? Now, not how many people, but how many groups of 9 people. Be careful. A lot of people make that mistake. They start saying, well, oh, 9 people can fit in. No, there are 9 people in one group. Now, our question is how many groups of 9? So I know that one group has 9 people in it. And if there are 13 chairs, then one group will take up 9 of the chairs. Now, 2 groups would be 18 people. That's too many people. And we can't seat a part of the group. It's all or nothing. It's everybody. Excuse me. So we can't seat, right? Only part of the group. We got to seat everybody. Everybody's got to have a seat, right? So it's all or nothing. It's everybody or nobody, right? So one full group can sit down. Now, since I know that one group of 9 people can sit down, that means that 13/9, my whole number part is going to be 1. Because the number of groups that can sit down is going to be your whole number. Just like in these mixed numbers, we have 31 and 6. Those are the whole numbers, right? Now, we still need a fraction. The numerator is going to be this. The number of chairs that are still empty after that amount of people sits down. So if there are 13 chairs and 9 people sit down, because one group sat down with 9 people in it, how many chairs are left? Yeah, you do 13 minus 9, which leaves you with 4. So 4 is your numerator. And the other thing about converting improper fractions to mixed numbers is this. The denominator never changes. The denominator was 9. The denominator is still 9. So we got 1 and 4/9. Now, that's only the 13/9 part. That's not the final answer. So now we got to do 37 plus 1 and 4/9. So the whole number is 37. And this whole number is 1. So that gives us 38 and 4/9. That's our final answer. 38 and 4/9. All right. I hope that was helpful. Please like the video, share the video, subscribe to the page if you haven't subscribed already. Tell as many people you can about the page. Tell them about what we're doing over here, all this math. We're trying to bring mathematics and mathematical literacy to the community, free of charge, direct to you, all right, to supplement and provide video support, self-paced video support to the community, to the people, to the youth, to the parents that want to learn how to do math so they can help their own children with their homework, whatever. That's what we're trying to do over here. So please subscribe to the page and let people know about what we're doing. And as always remember that there's all this math all around you.